Okay, I'm Evgenii Sorokin, and I'm a machine learning engineer in Toloka. And today I will be talking about human and ML collaboration in data labeling. Before we start, we'll go through agenda. Today we will cover 4 main topics: the pillars of modern artificial intelligence, experiments and improvements on annotation process, a slight touch about smart aggregation, and what is a human-in-the-loop pipelines and how they differ from traditional machine learning pipelines, which all of you already know probably, and questions in the end. So, what technologies depend on data? A simple answer is most of the products which work closely with customers, clients depend hugely on data because you have to provide personal suggestions in products, songs, etc. Or on the other hand, you'll have a translation systems from one language to another, hopefully in real time, or navigation for self-driving cars. If you want to make a competitive, good enough product with machine learning, you have to obtain high quality data. The next question is where to take it? Where can you obtain it? Probably open source datasets, but they are not usually enough to solve your problem. So the next slide tells us about the pillars of artificial intelligence. All of you know algorithms, hardware, and data. For the algorithms, what is the convenient way? What do you use to create a model that will predict labels, somehow infer what is inside of the minds of this mind. For the hardware, this is a term about hardware resources like CPUs, TPUs, GPUs, on top of which you train your models, and the data, where from you take insights about your clients. For the algorithms, of course, it is convenient to use deep learning libraries like TensorFlow, PyTorch, or tree-based libraries, Scalable and CatBoost. For the hardware, it is easy to rent in clouds on platforms like Amazon Web Services, Google Cloud, and so on. For the data, it is less convenient. There are many websites with datasets, prepared datasets, but what if your specific product, your specific domain differs a lot, or at least just differs from what is present in online versions? You would have to solve it somehow. Let's take a look. Let's focus on the last pillar about data. What kind of data exists? I will split them into 4 parts: unsupervised, supervised, semi-supervised, and human-labeled. Unsupervised data, of course, it is present in huge amounts and generated on a daily basis in all social medias and everywhere else. Unsupervised data can explain well your domain, but unfortunately, okay, let's start with fortunately first. Fortunately, it is a good data for pre-training of large models. Unfortunately, unsupervised data doesn't explain well insights from your data. If you want to make a competitive product, machine learning model, you need supervised data. But very often, the amount of supervised data is very low, and ideally, you want to transform somehow unsupervised data into supervised data. What happens usually is you create a model that is trained on top of somehow present supervised data, and all the data points that you infer, you trust your model. And okay, let me explain once again. You have a lot of unsupervised data points that come on a daily basis to your system, and you predict using your model, and now you have the labels. We may call it semi-supervised data now, because we cannot fully trust the model itself. It has quite a bias. So if in future you will retrain your model on top of semi-supervised data, you will ever grow the bias itself. There are a lot of studies over it. But what if there would be a solution for you to improve the quality of semi-supervised data, or a convenient way to transform unsupervised data into supervised data? It can be done with human-labeled data. So how company can make it? How to label data? Well, there are at least 4 approaches. The simplest option is to label it within the company. You just take a fraction of your employees and ask them, please, guys, manually label all of those pictures, texts into labels. So in future, we will train a model which will be good enough. Of course, because those are your employees, they know well what to do, understand domain, and you can easily explain what was their decision over it. Unfortunately, it takes time of your employees. It is not scalable because it is limited just by the number of employees that works over it. If you don't want to utilize your employees for it, you can hire some temporary employees, freelancers for it, but it has a drawback. You have less control over it, over quality, I mean, and of course it will be more expensive. On the other side, your employees are now free to do their job. Good. Maybe something else. Yes, takes longer. There was a message in Zoom chat about synthetic data. Synthetic data is also a possible solution for creation of data for future training of your models, but the problem is it hardly reflects the reality of your domain. Yes, you can generate data, but the price of a mistake can be high, that you trained the model on top of it, but in result, it didn't reflect the real situation. Yes, of course, it will save you time and money. Next, crowdsourcing approach. There are so many members in crowdsourcing that it is easily scalable, and thus it is fast. The time is not a question anymore. So any amount of tasks will be labeled within acceptable time. And once again, as there are so many participants, you can customize your tasks, make them very hard, very tough to understand, but still there will be enough participants to make that kind of task. On the other hand, you have to worry about how to transform multiple answers of unique participants, annotators, into a single label. This is what I mentioned, must be able to extract the positives. On the other hand, like my colleague on the previous talk, you need a quality control tools. Otherwise, some people will upload some bad pictures that do not make any sense. That's why we have Toloka, and I strongly suggest you to utilize automatic quality control tools. Okay, great. Let's move further. How can we improve annotation process with machine learning tools and methods? First of all, we will ask ourselves, what is our focus of improvements? We can improve the quality of annotated data, or we can improve the speed of annotation process. By speed, I mean the time between submission of tasks and receiving of results. The options that you see on the screen, they tell us how to improve the quality from the perspective of Toloka, of annotator. But maybe we can improve it from another perspective, from the platform perspective. In simple words, it is much easier to build a house if you have proper tools. Much easier than with your bare hands. Okay, next. On which stages on the platform, we can help with annotation. We can prepare somehow data before it appears in front of Tolokers. We can improve user experience, interaction, somehow modify aggregation with smart keyword, and utilize prior knowledge about the tasks. Okay, next. About pre-annotation, assistive bounding box annotation. We can pre-annotate objects and just ask a Toloker to tell us whether it is a correct pre-annotated object, correct pre-annotated suggestion or not. So it will dramatically speed up the annotation process. Two other items in this list tell us about experiments on experiments on improvements sorry, I forgot the word. Never mind. Interface improvements. Okay, let's go further. Idea is very simple. One option is let's ask Toloker to simply tell us whether or not the suggested rectangle around the object is correct or not. Another option is to ask Toloka, please put a dot in the center of an object, which we need to annotate, and some tool will somehow create a rectangular proposal around it. Sounds cool. It seems to be a very good idea. The problem is neural networks that do this kind of stuff are limited by the set of labels. And as a result, people come to Toloka with more complex labels than we expect on some kind of public data sets for SOTA, for state of the art. So when we tried it in Toloka for our projects, our Toloka project, it appeared to be that current state of the art models did not satisfy our quality requirements. For simple categories, mean average precision was very high, acceptable. But for more complex objects like human hands and heads, they were terrible. Thus, we decided not to use it. Well, it happens that not all of the experiments end up well. Okay, next. Oh, what's wrong? Yeah, extreme points clicking. What time do we have? Extreme points clicking? One of the articles state that instead of clicking 4 points around the object, like left, upper right, bottom left, bottom right corners, we can ask annotator to click on the bottom, upper, leftmost, rightmost points of an object, and it will automatically create a rectangle the same way, yes. And the authors of this article state that it makes the process much faster. Unfortunately, our experiment showed that it doesn't work. For professional skilled Tolokers, it makes no difference for them to use either an old approach or a new approach. It is the same for them in terms of quality and in terms of time. But for the new Tolokers, that less skilled Tolokers, I mean, that are already used to an old method, it is very unusual, hard to understand way. Thus, they didn't like it. For the insights, it appears to be that people using this new method, extreme points clicking, still continued to label data just like the old method by selecting leftmost or upper left, upper right, etc. points. And later, most of them were fixing the rectangle size each time, which takes time, of course. And still another one experiment that didn't end up well. But we have good results as well. Guidelines annotation. We simply improved an old method of rectangular annotation by adding guidelines which help Tolokas annotators to understand which easily explains with horizontal and vertical lines the projection of your object, where it will be. So you need to click, you need to put just 2 dots. It ended up in an improvement of 10% speed up in terms of time. Good. Let's go further. There is a small investigation study about multilabel classification. Imagine you have a problem that you need. Oh, okay. Let me first explain what is multilabel. Multilabel is a classification where a single example can have several final classes. Unfortunately, it appears to be that it is a hard task. It is non-trivial task to be solved. This is an example of interface in Toloka. There exists the problem of dimensionality. Imagine you have 20 classes to be marked. The task asks you select services that the statement belongs to or refers to. And a single statement can have, I don't know, from 1 to 10 to 20 items. In your particular project, you have 60 labels. Unfortunately, it is not comfortable for annotator to search through them. So you need somehow to reduce the amount of final labels for the Toloka. How can you do that? Here I just summarize my previous thoughts. In most of the cases, only a single option is selected. If you want to make it simpler, you can go with divide and conquer approach. You can go and utilize divide and conquer approach via hierarchical classification or binary classification, or utilize both of them, hybrid approach of some kind. So if we will use hierarchical group classification, we need to make a higher order groups which will combine classes that usually meet each other. So if you select a single group, it will be much easier for a second classification to select between 3 options, but not between 11 options. That is it. That is the idea. And so for binary classification, you can transform the whole problem, either group or all the classes, into multiple questions of binary type. You simply show to unique Toloka a unique question. There is a statement for Toloka number 1. You ask him, is it performance and compatibility? Is it about X or is it about Y, Y, and so on? And afterwards, you combine those answers into the same kind of structure for multilabel answer. Great. So those were just 2 ideas on how to improve multilabel classification. Next, about smart aggregation. As you already know, if you want to get the final result label from multiple answers of Tolokas, you have to utilize what is called an aggregation. Aggregation may differ from aggregation techniques differ by complexity, starting from majority vote and ending with David skin and more complex ideas. So, okay. Can we improve it somehow? Of course, first option of approval is skill-based aggregation, what is present in weighted majority vote and David skin and others, which I will not talk about. And the other improvement is about overlap, fixed and dynamic overlap. Yes, let me first explain you. About the notion of overlap. The dynamical overlap means that you will ask as much Tolokers as needed for that particular task. If the task is very simple, you will ask less. If the task is very complex, you will ask more until you get coherent, consistent answer. But now, what if we will utilize a virtual labeler, what I call also a prior knowledge? Let's train a model, fine-tune a model on a markup from Tolokers and validate it the same way as Tolokers. So we will end up with skill of some value, and we can use it. Thus, we can use it in aggregation. Combine both annotators and model answers and see what happens. It ends up that it speeds up the annotation process and improves the quality. It works well for all of the cases that are listed here. Great. And as I said earlier, it can allow us to reduce the dimensionality of multilabel classification, several slides before. Good. Here you can see a plot where we compare the model skill against Toloker skills. Good. Here, once again, the notion about dynamic overlap. If the task has more complex example present, the more answers you would need to obtain agreement between those. Sorry for that. Here you can see as well quality evaluation between test tasks, between Tolokers and the model. Okay, that is not very interesting. Let's continue. The first client demo demonstrated that inclusion of virtual Toloker allowed us to improve the accuracy by 2%. It reduced the time needed by 30% and reduced the overlap. It means the amount of needed human labels, human answers. For the second client demo, it was a question, is that particular English sentence correct or not? There were many sentences generated either by a human, or by human I mean taken from the book, or generated by language model like transformer. And we had to answer, humans and virtual labeler, whether or not it is generated or real. The inclusion improved accuracy by 5%. Magda, sorry, do we still have time, or do I need to finish?
I think we can stay a bit longer and maybe try to wrap up a bit quicker. Okay. But I think if you guys still interested, please stay a few minutes more so Evgenii can finish.
Okay. Okay, next. Okay, sorry. They're asking to leave. Human in the loop process, and what is the difference of it between how inclusion of human into the machine learning pipeline improves the quality of a model and so on. You see, the classic machine learning process looks like this. You collect in offline method your data and train the model. It works and you obtain the labels to every data point. But what is bad in this approach The bad is that you don't have an idea about what happens right now in the reality. They can occur data shift through time, and you don't have ground truths to compare the model answers to. So, a real example, for example, imagine you trained a sentiment model that performed well on training, but in reality, after you validated it a week later on human labels, you see that there is a huge performance drop over all the classes. Next, what if you will insert humans into your loop? So thus you will be able to reevaluate your model on a regular basis and see what happens with it. So there will be human labels for training and no 3 minutes. Okay, sorry. See, and you obtain real labels. Sorry. Okay. I think we need to end up. Summary. We talked about 3 pillars of modern AI, how improve an annotation process, a bit about smart aggregation, and how the human in the loop pipeline improves your model. Okay, thank you. Sorry, but I have to leave. I'm still here, but I have to leave the room.